Hello everyone, welcome to this video on analytical simplification. This is unit 6 of computer method in power system BTech. Now in this video we shall explain how we can analyze line to line fault using two component method. So this is the question that appears in the university question paper. So let us consider a three-phase system shown here and consider a line-to-line fault on phase B and C. So you can see here we have three lines A, B and C, and two lines they are shorted through a fault impedance ZF, and these are the voltages shown VA, VB, VC, the voltages of each of the phase with respect to ground. And now for this fault, we can write the boundary conditions. So we can say here I naught is 0. There is no current in this line phase A. And IB is equal to minus IC. So you can see the IB flows in this way and IC flows in this way to the fault, and they are opposite. So we can write IB is equal to minus IC. And now we can write a third boundary condition is VB minus VC is equal to IBZ. So here the potential is VB, so this is VB, and here the potential is VC. So the difference in the potential, which is equal to the voltage drop across the fault impedance. So it is IB into ZF. Now based on these boundary conditions, we have to find out how we can interconnect the sequence networks of two component method, that is zero sequence network and positive summation network and positive difference network. So let us find it out. So from two component model of current, so this is the two component model we are using here. So IA naught, this is the sequence current of zero sequence network. IA summation, it is the current of positive summation network, and IA delta, it is the positive difference current. Okay, and now here we have IA, which is IA, IB and IC, and IA we are putting it in 0 here. IB is kept as IB, IC it is substituted as minus IB. So as per this equation, and now we get here IA naught as 0. So what this IA naught implies 0, it means that the zero sequence network is not existing. Means you need not to analyze this network for finding the fault current. Next, IA summation is 0. It implies that positive summation network is also not existing. Is also not existing, or you need not to analyze it. So only here we have non-zero value. It implies that we have to analyze only difference network, positive difference network to find the fault current. So in our interconnection of networks, we will have only positive difference network, whereas zero sequence network and positive summation network will not be existing. Now, similarly using two component model voltage. So this is a two component model in terms of voltage. So here we have VA, VB, VC, and VA naught, VA summation, and VA delta. Now here one point to be noted, as already told, H can be taken as 1. Here also H can be taken as 1. In the exam also you can write, please replace this H by 1. Okay. Now from this equation, we can write VB, that is VB minus VC. So we can write one equation for VB. Okay. And then we can write equation for VC. Now subtraction of these two equations, we get this minus j root 3 divided by H. H can be taken as 1 VA delta. Now from above equations, Now from this equation and this equation here, we can obtain this equation. So what is done here? Mm, mm, okay. Now this VB minus VC is equal to IB into ZF. You can see here it is from our these boundary conditions. And but what is IB? IB you can get it from this equation in terms of, so here you can see IB is equal to IA delta 3 divided by 2 root 3 j. So we can put here j and this here. So this value you can substitute here, and then from that equation we can get VA delta is equal to ZF by 2 IA delta. Now this is the equation of the network positive difference network. So from this equation we can draw the positive difference network here. So you can see here this is the positive difference network we have drawn. So you can see this is VA delta equal to ZF by 2 into IA delta. So from this equation we can draw this network. So as I told earlier, there will be only positive difference network which we know to analyze, whereas the negative sequence network and positive summation network, they are zero. So here it is written positive summation network is zero. Now from this equation, from this network, we have to find out, uh, we can find this fault current I delta as HVF divided by Z1 plus ZF by 2. Okay. Now H is equal to 1 as already told, and Vf, it is the Thevenin voltage seen from the fault point, and Z1 is positive sequence impedance and ZF is the fault impedance. Now once we get I delta, then we can find IB from this equation. So as already told, so I delta is known, then we can find IB current. Okay, so this is how we can find the fault current. And what is IC? IC is equal to minus IB. So we can get both the fault currents in both the phases. So this is how we can analyze line to line fault using two component method. So in this video up to this only. Thank you very much. We'll continue in the next video.